So we talked about relative risk, and now we're going to talk about two other measures of risk: relative risk reduction and absolute risk reduction. And the content for this video comes in large part from this article cited here, Barrett, Wire, et al., Tips for Teachers of Evidence-Based Medicine, Relative Risk Reduction, Absolute Risk Reduction, and Number Needed to Treat. So this graph shows the results of a randomized controlled trial that's looking at the effectiveness of a new treatment for to prevent myocardial infarction or heart attack in patients. And the y-axis here is 30-day mortality rate. So what this blue bar shows is among the high-risk patients in this trial who received the placebo, in people in the control condition, 40 out of 100 patients died within 30 days. And among those who received the drug, 30 out of 100 patients died within 30 days. So as you know, a mortality rate is a measure of incidence, and so these bars are measures of incidence for each of the groups, so incidence of mortality in each of the groups. So as we know, incidence is the number of cases over the number of people at risk for the outcome. And so this blue bar is an incidence of 40, incidence of mortality of 40. So 40 patients died within the 30-day period out of 100 patients. And the same is true for the treatment group. So another way of referring to incidence is absolute risk. So the absolute risk of death in the placebo group is 40%, and the absolute risk of death in the treatment group is 30%. So just two different ways of referring to the same number. So what do we want to know when we're looking at these data? We want to know, it's a trial to test the effectiveness of the treatment, so we want to know the effectiveness of the treatment. And one way of looking at that is to look at absolute risk reduction. So what is absolute risk reduction? It's the reduction in absolute risk. So absolute risk of placebo is, in this case, 40%, and the absolute risk in treatment is 30%. So the absolute risk reduction then would be 10%. So the absolute risk reduction is just the difference between the placebo and the treatment, the absolute difference. So we've looked at absolute risk reduction, and now another way of looking at change in risk is to look at the relative risk reduction. So the formula for relative risk reduction is just 1 minus the relative risk. So to calculate that, let's first calculate the relative risk. So relative risk, we remember, is the incidence in the exposed group over the incidence in the unexposed. And so here, what is the incidence in the exposed? So which is the exposed group? Well, we're looking for the effect of the treatment, so the treatment will be our exposure. So what's the incidence in the treatment group? That is 30%, so we're going to write it as 0.3. And then what's the incidence in the placebo or the unexposed, which that is 0.4. And so that equals 0.75. So then relative risk reduction would equal 1 minus 0.75, which equals 0.25 or 25%. So that makes sense because you can see that the treatment group is 25% lower than the placebo. So it's 10% lower, 10% is 25% of 40%. So the relative risk reduction is 25%, absolute risk reduction is 10. So there's slightly different ways of looking at the same numbers. So let's look at the same drug but in different patients, in a different group of patients. So this graph now shows a second trial where the same drug was tested in a set of lower risk patients. And so we can do the same thing. We can calculate absolute and relative risk reduction. So the absolute risk reduction for trial 2 is the absolute risk of the placebo, which is 10%, minus the absolute risk of the treatment, which is 7.5%. And that equals 2.5%. So with the lower risk patients, we can see that the absolute risk reduction is much smaller. And in general, that's true. If you have lower risk population, then your absolute risk reduction is going to be a lot smaller than if you have a higher risk population. So remember that in trial 1, the absolute risk reduction was 10%. So now let's calculate the relative risk reduction for trial number 2. And so we remember that that equals 1 minus the relative risk. So for the relative risk, we want to look again at the incidence in the exposed group, which in our case is treatment. So that is 0.075. And then over the incidence in unexposed, which is the control group, so that's 0.10. So this equals 0.75, and then 1 minus 0.75 is 0.25. So the relative risk reduction is 25% in the trial 2 with low-risk patients, and the relative risk reduction is the same with the low-risk patients as it is with the high-risk patients. However, you can see that the number of patients who are actually affected is much smaller in the low-risk patient trial than it is in the high-risk patient trial. So in general, when talking about these different measures of risk, relative risk reduction is going to make the effect look a lot bigger than is absolute risk reduction in many cases. So for example, often drug companies might test out a drug using high-risk patients, thereby getting a big absolute risk reduction and being able to claim that they prevented the outcome in a large number of people. But then in practice, the drug is used with lower risk patients, so the overall effect is a lot smaller in the low risk patients, even though the relative risk reduction is the same. So it's important to understand the implications of using each of these different measures of risk reduction. So in a later video, we'll talk about number needed to treat, which is a measure that can help understand the impact in terms of numbers of patients of using different interventions, and that is calculated using the absolute risk reduction number. So we'll see you in the next video.